There are two very important theorems of moment of inertia. First is theorem of parallel axis and second is theorem of perpendicular axis. So first we will see the theorem of parallel axis, then we will move on to the theorem of perpendicular axis. So it states that the moment of inertia along an axis is equal to the moment of inertia along an axis which passes through the center of mass of the body and parallel to given axis plus the product of the total mass of the body and square of the perpendicular distance between them. So what does it mean? Let us take a rigid body and suppose if we want to find out the moment of inertia along AB, IAB, so by this theorem we can find it. It states that the moment of inertia along an axis AB is equal to the moment of inertia along an axis which passes through the center of mass of the body. Suppose an axis KL is passing through the center of mass of the body and parallel to the given axis, and this axis is parallel to the AB. Plus the product of total mass of the body and square of perpendicular distance between them. Suppose h is the perpendicular distance between them. So IKL is the axis which is parallel and passing through the center of mass plus the product of total mass of the body and square of perpendicular distance between them. So perpendicular distance is h and its square. So this is the theorem of parallel axis. From this theorem we can find out moment of inertia of any axis which is parallel to the center of mass of the body. Now we'll see the proof of this theorem. Again take this body and AB is an axis and KL is a axis which passes through the center of mass and h is the distance between them. Take this body consists of n particles of mass m1, m2, m3 and so on up to n particles. So let us consider a body of n particles consisting of mass of particles m1, m2, m3 up to mn. And let the and let R1, R2, R3 up to Rn be the distance, be the perpendicular distance of particles from KL axis. Let R1, R2, R3 and R to Rn be the perpendicular distances of the particles from KL axis. So moment of inertia along KL axis can be written as the summation of moment of inertia of all the particles from this axis. So see, if there is a particle m1 and its distance from KL axis is r1, then moment of inertia of that particle from this axis will be m1 r1 square, and from m2 mass m2, then the moment of inertia of that particle is m2 r2, and for whole body thus the moment of inertia of whole body is the summation of whole moment of inertia of each particle from this axis. So m1 r1 square plus m2 r2 square plus and up to mn rn square. So this is the moment of inertia of whole body for the along the KL axis, and I can write this as summation of mi ri I is 1 to n. Suppose take a particle, random particle, which is at ri distance from KL axis and having mass mi. These all are identical particles, so I can write this as mi ri, and I can vary from I to 1 to n. So this is our equation first. See, this is ri distance from KL and this is h distance from KL. So the total distance of this particle from AB axis is ri plus h. So I can write the moment of inertia along AB axis is summation of I is equals to 1 to n mi ri plus h whole square. IAB is equals to summation of MI by opening this whole square we'll get Ri square plus h square plus 2Ri h. And IAB is summation mi Ri square plus summation mi h square plus 2 is constant, so we can take it outside from the summation, and h is also constant. Then I can write 2h summation of mi Ri. So this is our second equation. Now see, the torque along the center of mass of the body is 0 because the radius for it is 0, so the center of mass is 0 from the heel axis. Torque is 0, so I can write as torque along the center of mass of body is 0 as the whole body is balanced on the center of mass. So torque is M1 G R1 plus M2 G R2 up to Mn G R N, because this is the force and this is the perpendicular distance, so I am writing it directly, and from here we'll take G common, so here we'll get this equation. As torque is 0, so this whole equation is 0. As g is the acceleration of gravity, which cannot be 0, so this whole equation is, so this whole term is 0, and this whole term is 0, that means the summation of mi Ri is 0. This is mi Ri summation. Now we'll put this equation in this equation. We'll mark this equation as third equation. So we will put equation first and third equation in equation second. So we'll get IAB is equals to summation of mi Ri square. This is IKL from equation first. from this term h square is constant, so we can take out this h square from the summation. So, and summation mi is the total mass of the body, so I can write it as capital M, plus from equation third we can see summation of mi ri is 0, so this term is 0, the whole term. So IAB is equals to IKL plus MH square. This is our theorem for parallel axis. So in the next video we will see the theorem of perpendicular axis.